This video presentation is regarding our embedded system project Bidirectional visitor counter using Arduino. The team consists of 3 members, including myself, Sameer Pathan, 14BC0013, Rohit Ranjan, 14BC0661, Ayush Yadav, 14BC0680. We are doing the project under the guidance of Dr. M Rajasekhara Babu. So, giving you the outline of the presentation, it consists of the following parts: importance of the area, problem statement, objectives, feasibility analysis, scope of the project, functional requirements, non-functional requirements, model, requirements, both hardware and software. Today, automated decision making is of utmost importance, especially when we consider the need of quick and efficient responses to be provided for statistical responses given to a certain query. Considering the implications of numeric count of a given occurrence and the conditional responses that we may expect as the output, an efficient counter holds the utmost importance in today's world. Our design idea for the project was to replicate a distinct entry and exit room where a person would enter a room from one side and exit a room from the other side. Many a times we need to monitor a person or people visiting the same place like seminar hall, conference room or shopping mall or temple. The project can be used to count and display the number of visitors entering inside any conference room or seminar hall. This is a bidirectional counter, which means it works in a two-way. That means counter will be incremented if the person enters the room, and it will be decremented if the person leaves the room, and counting is displayed on an LCD through the controller. Summarizing the importance and need of bidirectional visitor counter. In large events, it is often important to keep a count number of visitors and attendees for management or safety purposes. This requirement is fulfilled using a bidirectional visitor counter, which can count the number of people both entering and exiting an area. It works in both directions. We use an Arduino microcontroller in implementation of bidirectional visitor counter. The problem statement for this project is to develop a bidirectional visitor counter using Arduino microcontroller, which can count the number of persons entering or exiting an area accurately. The objectives are: this is an economical cost reducing system which, when implemented in places where the visitors have to be counted and controlled, to accurately and precisely count the number of visitors with low error rate, to require minimum maintenance and offer maximum uptime. The objective of this project is to design a controller-based model to count the number of persons visiting a particular room by incrementing the counter by 1 when someone enters the room. Here we are using sensors and controller to count the number of persons and displaying the count on the LCD. This is an economical cost reducing system when implemented in places where the visitors have to be counted and controlled. Counting the visitors can be time consuming, so it helps to maximize the efficiency and effectiveness of employees, time saving and sales potential of an organization. The feasibility analysis. Our proposed model is feasible both technically and economically. The parts required in our model, such as the sensor and the microcontroller, are easy to acquire and can be purchased at inexpensive cost. The parts are easy to operate, and the working parts can be learned without much technical knowledge beforehand. The project can also be deployed without much transportation cost, as it is small in size. Moreover, the parts are not fragile and unlikely to break. The scope of the project. The primary stakeholders of a project are the organizers of large events which require accurate counting of the number of visitors. Some risks faced by our model include malfunctioning of microcontroller or sensor, loosening of connecting wires, fault in LED display, or tampering in general with the equipment. The project can be deployed at any entry or exit point which requires monitoring over extended periods of time for counting visitors. An early approach presented in 2017 presents the implementation of bidirectional counter using latest technology, IoT. The work proposed here is an approach to enhance old appliances and the controlling experience through an IoT. The sensor data are processed by Arduino and delivered to mobile applications through wireless connection. This project minimizes the power consumption with the help of sensor module and LDR module. Using IoT, according to the number of visitors in a room, the lights and fans are controlled, and it automatically controls the lights based on the intensity of the room, and if there are any fire accident, it gives alarm and automatically flows of water into the fired place. Another approach proposes bidirectional visitor counter and Arduino as master controller. The total number of persons inside the room is displayed with the help of Arduino on LCD screen. The signal is being received from IR sensor. In the system, it has two sections. One, the transmitter section where the power supply and light output is given. The other one is the receiver section where light output input is taken and implemented or enters sensor circuit and exits sensor circuit. The IR sensor modules contain IR diodes, potentiometer, comparator, and LEDs. The overall implementation and cost of this method is very cheap and is affordable by a common person. The functional requirements for this project are: the system counts both the entering and exiting visitor of the auditorium or hall or other place where it is placed. On the successful implementation of the system, it displays the number of visitors present in the auditorium or hall. The system should increment the visitor counter at entry gates whenever a new visitor passes by the gate. The system should decrement the visitor counter at exit gate.
My name is Rohit Ranjan, 14BC 0661. So from slide 8 I will continue. So these are the non-functional requirements of our project. So the first one is the system should have low error rate and be accurate. So the chances of error should be as minimum as possible and accuracy must be as maximum as possible. Second is the system should have fast response time. So by the response times we means length of time taken by the system to react to an event should be as minimum as possible. The third one is the system should have high capacity counting mechanism and be high in robustness and scalability. So here robustness means it should be in good condition, and scalability means the ability of a process to be used in range of capabilities. And high capacity counting mechanism should deal with the large number of visitors coming in and coming out and going out for the room. The system should be secure and portable. So portable means easy, that can be easily carried or moved because of its smaller size as compared to other systems. The system should have fault tolerance and high maintainability. So fault tolerance is the property that enables a system to continue operating properly even in the event of failure of some of its component. Maintainability means performing a successful repair action. The system should be properly documented or supported and tested. So it should be properly tested to check qualities, performance before putting it in actual use. So basically this is the circuit diagram of our project. We have taken two IR sensor models, one Arduino and LCD. So the output of IR sensors modules are directly connected to Arduino digital pin number 14, that is A0, and 19, that is A5. And this is relay driver transistor at digital pin 2. Now we have one LCD connected here which is of the size 16x2, and LCD is basically connected in 4-bit mode, which is used to display the current status of the hall auditorium. And we have RS and EN pin of LCD, which is directly connected to 13 and 12. And data pin of LCD from D4 to D7 is also directly connected to the Arduino D11 to D8 respectively. Rest of the circuits connection are shown in the diagram. Moving next we have list of hardware components. So first is Arduino UNO. So basically it's a microcontroller board having 14 digital input output pins, 6 analog input, a power jack, a USB connection, an IC SP header, and a reset button. Now the second is relay 5 volt. So relay is an electromagnetic switch operated by a small current that can turn on or off a much larger electric current. And third we have resistors. So resistor is a two-terminal electrical component used to reduce current flow. Now the fourth is IR sensor module. So IR stands for infrared sensor, which is used to sense certain characteristic of the surroundings by either emitting or detecting infrared radiation. Fifth is 16 cross 2 LCD display. So LCD display is used for displaying current number of person in the room. 16 cross 2 is the size of LCD. Now the sixth is breadboard. So breadboard is just for setting up all these components, including connection wires, LED, resistors, relay, and Arduino. So seventh is connecting wires. Connecting wire provides a connection for flow of electric charges. Now the eighth is LED. LED stands for light emitting diode. It's a 2 LED semiconductor light source. The last one is BC547 transistor. So BC54 transistor is NPN bipolar junction transistor, and it's used to drive the relay because Arduino does not supply enough voltage. Now we have description of hardware component. So the first one is name of the item, it is model Arduino UNO SMD R3. So price is Indian currency 450 approximately. So the specs are 2 kb SRM, 80 mega 3280p microcontroller, 16 megahertz clock speed, and 32 kb flash memory. So description we have Arduino UNO is used for building digital devices and interactive objects that can sense and control objects in the physical world. So basically it's a microcontroller board based on 80 mega 328. The same case as I explained in the previous slide, it has 14 digital input output pins, 6 analog inputs, a 16 megahertz crystal oscillator, a USB connection, a power jack, an ICSP header, and a reset button. So it contains everything needed to support the microcontroller. Simply connect it to a computer with a USB cable or power it with a AC to DC adapter or battery to get it started. The next one is BC547 transistor. So you can see it has three parts: emitter, base, and collector as shown in that diagram. So BC54 transistor price is 100 for 10 pieces. Specs are collector base voltage 50 volt, collector emitter voltage is 45 volt, emitter base voltage 6 volt, collector current DC 100 milliampere, collector base reservation power 500 milliwatt. So BC547 is an NPN bipolar junction transistor, and it's mainly used for amplification and for switching purpose, and it also has a maximum current gain of 800. So it's an NPN bipolar junction transistor. A transistor stands for transfer of resistance. It's commonly used to amplify current. A small current at its base controls a larger current at collector and emitter terminals. Now next we have list of softwares. So Arduino IDE, the version is 1.8.4. Description is the Arduino IDE is an open source Arduino software which make it easy to write code and upload it on the board. It can run on Windows, Mac, or Linux. The environment is written in Java and based on processing and other open source software. The software can be used with any Arduino board. You can find more details on this reference website. And this is the last part. So the first one is automated light controller with visitor counter. First reference paper. Second is automated loom light controller with visitor counter, and it's published by Daspi and Rohit. The third paper is bidirectional visitor counter using IoT. The fourth paper is design and construction of a bidirectional digital visitor counter. The fifth paper is the prospects of bidirectional counter system in the hotel industry, communication on the applied electronics. So thank you.